Hi, everyone. So I've got about 20 minutes to talk about domain and DNS safety and talk about how we can do better for both ourselves, but for the general internet. So firstly, who am I? So I'm Michael Kehoe. I'm a senior staff security engineer at Confluent. I'm in a team called Cloud Architecture and Reliability. That means a lot of different hats, doing a lot of different things. Previously, I was a senior staff SRE at LinkedIn. The coolest thing on my LinkedIn profile is that I used to work on a project as an intern at NASA called PhoneSat. I've worked in a bunch of different spaces, networks, microservices, traffic, key value databases, incident management, done a bunch of things. Part of those things is writing these two O'Reilly books. I was just discussing with Brendan earlier about some other projects that are in the works for later this year. So let's talk about threat models for DNS and domains. So this is by no means a formal threat model, but it does sort of highlight some of the things that we need to think about for our the stability and the availability and the security of the services that we run on the internet. So if you look at the threat and the sort of the property that it affects, you can see on the right-hand side the examples. So if we look at denial of a service, that affects availability, means that we can't resolve DNS records for our domain. If the attack is spoofing, we're not authenticating something properly, people can do bad things. So mail spoofing, or even like typo squatting, bit flipping, or using homoglyph domains. So people, either intentionally or unintentionally, are going to domains that look like yours but aren't actually yours and can be used for malicious purposes. Tampering, which impacts integrity. So an example of this is DNS responses being modified in transit, sending you to a different destination than what is intended. Repudiation and non-repudiation. So can we actually validate that this mail is from this particular person? And then information disclosure and confidentiality. So people intercepting DNS traffic. This is a worry within a bunch of nation states, but also goes beyond DNS. For a long period of time, mail was sent, unencrypted. And there are still a bunch of layer 7 different applications out there that are still unencrypted. So, as a part of a side hobby project, not related to my job, I decided to start researching how secure is the general internet. So I went to Cloudflare. They have a really cool tool called Radar. And part of this tool gives you, the most trafficked domains. So I started with 1,000 because that's a reasonable number to process. For the purposes of these statistics, I'm only using 929 domains because I couldn't get full results for a handful, unfortunately. So we've got 929 domains out of the top 10,000. So before I go through the statistics, how many do you think are following all of the best practices for domain and DNS security? Just shout out some numbers and I'll repeat them. 5%? 10%? 2%? Two total? Price is Right rules. This gentleman wins. It's actually 0. And we'll go through why that is in a moment. All right. So who's heard of domain locks? A handful of people? OK, we'll go into that more in detail. So there are 6 different types of domain locks. Only 17% of this top 10,000 actually implement all of the domain locks. We're doing a little bit better. 38% implement half of them. 36% of them, those domains only have one of these locks. And then 9% have 0 of these locks, which is really scary because, these are the top 10,000 most trafficked domains on the internet. If we go and look at Nameserver Safety, the numbers are actually surprisingly better. I was actually genuinely surprised. 25% of these domains use more than one DNS provider. So you may have remembered the Dyn, I think it was, outage in 2014 or 2015 that took down a large piece of the internet. AWS has also had large DDoS attacks on its DNS infrastructure, and a bunch of people, actually I remember my Roomba being hosed because AWS DNS was down. But 25% of these domains actually have a diverse set of name servers, meaning that they are located on more than one autonomous network system. However, back to the bad news, only 5% of these domains implement DNSSEC, meaning that theoretically at least, the responses from the authoritative name services for these domains could be modified in transit, and the DNS client would be basically unaware because there's no integrity checking on the responses. Mail server safety. This was interesting. So 68% have an SPF record, which basically specifies what IPs can send mail as your domain. 58% have a DMARC record, which basically that's very unnerving, the shaking in the room. 58% have a DMARC record, which says what is the policy for messages that we are unauthenticated, which are sent without a DKIM record, which we'll talk about shortly. 0.2% have a TLS authentication record, so that's not great. And then 1.5% of these domains had an MTA STS record, which basically is a policy that says, yes, any incoming mail to me must be encrypted. Finally, 8% of domains have a security.txt record. This is a relatively new RFC. The draft was, had been in draft for probably 4 or 5 years. And then final good news, 25% of domains have CAA records, which states which certificate authorities can issue certificates for your domain. All right, so now that we've gone through this roller coaster of good and bad news, let's actually walk through what are the best practices. So let's start with domain registrar protection. When you go and register a domain for yourself at GoDaddy.com or Gandhi, you are given, depending on the registrar, the ability to add locks to your domain. Typically, if you're buying a domain for yourself, the lock you'll be able to buy is a client-transferred prohibited lock, which basically means that your domain is locked. If you want to go and move it to a different provider, you have to go and present an authorization code. There are 2 more of these, what we call client-side locks, for updating a domain record like a DNS record attached to the domain, or the billing address on the domain. There's also a client delete record, which ensures that you have to have this code before the domain can be deleted. For server locks, these are very useful, and hence why you want your domain to have them. The downside that they have is that they're really pricey. We're talking somewhere between $500 to a couple of $1,000s a year for each domain. And when you think about, you go and buy your .com domain for like $18, $19, this is quite pricey. But what the server lock gives you is you have to go through, your domain has a server lock, you have to go through a process with your domain registrar to go and remove the lock before you can go and make any modifications to it. So you have to go and follow some sort of process, give your domain registrar a password, a passkey, identify yourself before they will do anything with your domain. For the rest of us who don't need or can't afford server locks, there are other ways that we can protect our domains. So enabling 2FA on your domain registrar portal, putting IP controls on the portal, so you only can log in from certain IP addresses. And if you are registering domains for a business purpose, a lot of domain registrars also integrate with your SSO provider like Okta, which is a useful way to get more security in the management process of your domains. So I did mention that server locks aren't supported by everyone. Out of the top 10,000 domains, these were the registrars that we found that supported server locks. I doubt the list is going to be much bigger if I went to the top 10,000 or the top million. Mark Monitor is the most common for US-based companies. Cloudflare is probably the newest one, but it's very hard to find the registration on how to get it. All right, let's talk about Nameserver Safety. So we already touched on this, but essentially what we found is, and if you go and look at the global internet statistics, only about 5% of domains enable DNSSEC. So what DNSSEC gives you is when you have your DNS response returned to you, it's basically signed with a key, and so that response cannot be tampered with by a party in the middle, which does happen. ISPs do things all the time with rewriting IP records, or bad Wi-Fi hotspot portals do that as well. DNSSEC basically ensures that the response you're getting from the authoritative name server is true. Then, as I mentioned, using multiple DNS providers is another way to ensure the availability of your site or your infrastructure when it goes down. Having really long TTL records, I don't believe, is a good way to provide better availability. So, DNS records for mail. This is a very complicated space, and by no means am I an expert. There are actually experts here at the conference who have written some of these RFCs. But essentially, these are 6 different ways that you can go and secure your domain, your mail that you send and receive, using SPF, DMARC and DKIM, TLS authentication records. This is a DNS record that is basically a SHA-256 hash of your certificate public key, and then the client authenticating to the TLS server basically looks up the corresponding DNS record to make sure that the public key hashes match, and ensures that the integrity of the TLS connection is there. MTA STS is a policy that states that your domain requires authentication and an encryption for any SMTP connections. And then there's, in conjunction with that, you can use SMTP TLS, which is a standard which enables reporting for the sender's ability to send mail to your domain. So if people cannot connect to you, the sending client can basically send a report to a service which lets you know that your mail server is having connectivity problems. Similar process exists for DMARC today. And then finally, BIMI and VMC. BIMI is still a draft RFC, but essentially it allows you to add your logo to emails. So if you look at, if you get emails from LinkedIn, in Gmail, you'll see there is a verified tick beside those emails. That basically means that Gmail is able to verify that LinkedIn had a DNS record with a certificate which matched a certificate that Setego, I think, and VeriSign have. And it sort of provides an extra level of sort of repudiation, so you know that it is coming from LinkedIn. Some really good resources to find more information about securing mail servers can be found at Email Security Scans, which is a great service where you can actually go and you send them an email, they send one back to you, and it goes through a whole workflow of checking for all the best practices that are being applied. The support.google link on the slide contains more information about BIMI and VMC. And then mailhardener.com has more information on how to sort of go and validate and generate DNS records to secure your mail. As I mentioned earlier, only 68% of those domains had SPF records, and I think it was 58 had DMARC records. This is bad, which essentially means that while there are no guarantees, somebody could go and send emails as you on your domain. So if you have a domain that does not send mail, the best practice is to go and implement these DNS records, which basically say my domain doesn't actually doesn't send mail, so you should not be delivering mail from my domain. Quickly, some other best practices, implementing security.txt. This is a new RFC, which is a text file on a web server, which says, here's how you go and report security vulnerabilities, here's the policy, and here's where we advertise security jobs. And also implementing CAA records. All right, I've got a couple of minutes left, so let's jump to a demo. So who has heard of SSL Labs or tested their domain with SSL Labs? All right, a couple of people. Who has used securityheaders.com? All right, a couple of people. All right, so I was inspired by these two and created domainlabs.com to go and test how good each domain was. So I'm going to go and try and jump over to a demo. You can go to this domain today and test your domain. I am still working on hardening the infrastructure, so be nice. Out of the top 1,000 domains, yahoo.com had the best score. I did not see that coming, but that's kind of cool. There's a couple of really bad Hall of Shamers. Interestingly, that YouTube was still kind of low. So you can go and enter your domain. So this is the LinkedIn.com one. I wanted the Yahoo.com one. Yahoo have all the server locks, client and server locks on. They don't have DNSSEC though. They don't have a BIMI record, and they do not have a TLSA record. And funnily enough, they didn't have a robots.txt record that I could actually resolve. But otherwise, they had all of these other things implemented. So if you want to go and play with this, I do have some other features. You can go and see which registrars that we know about support server locks. I also added this while on the plane over here. These are domains that are expiring soon. Pendo.io is expiring on Saturday. You might want to keep an eye out on that and see if they go and renew it before then. GoogleAnalytics.com is also expiring next month, so we'll see what happens there. So feel free to use this tool, test it out. Hopefully later in the year, once I've got the infrastructure hardened, I'll also have an API where you can go and do your own research.